Let's evaluate another limit as x approaches infinity. And we'll evaluate this if we can, if it exists. If it doesn't exist, we'll still say whether it approaches, the y approaches positive or negative infinity, and of course we'll show work. Now there's not really any work for me to do up top. I do have a monomial, but down low we could do some simplifying. This will be the limit as x approaches infinity. I'm going to divide by that biggest power of x. I'm going to factor out an x squared. When I do, I'm left with 16 plus 9 divided by x squared, all under that radical in the denominator. Okay. Well, my next step is to say, now I could simplify here with the square root of x squared. It is written in factored form. That means I could take out an x down there. So I've got an x to pull out. I'm left with the square root of 16 plus 9 over x squared. Next, we'll do some simplifying. If I ask, well, where have we got more x's? They're the same. Psh. We get to cancel them between top and bottom. I'm ready to go ahead and plug in my infinity. Now, of course, we avoided plugging in infinity in the very beginning because we didn't want that indeterminate form. But we can go for it now. This would be the limit as x approaches infinity of 7 over the square root of 16 plus 9 over x squared. Well, now, if we divide 9 by something really big, that means we're dividing something tiny by something enormous, and that is going to approach 0. What this will be is 7 divided by the square root of 16 plus 0. That means we're going to have 7 divided by the square root of 16, which is just 7 divided by 4. So who knew, but the limit as x approaches infinity is 7/4.